Hi everyone, my name is Kate and I will today be teaching the H2O lesson. The supplies that you need for this lesson are plastic cups, markers, construction paper, and coffee filters. Fill one of these cups halfway with water and one of these cups all the way with water. We will be using these supplies for the activities at the end of the lesson. This is a water molecule. It is made up of 3 atoms. What do each of the letters on the atom stand for? Correct. There are 2 hydrogen and 1 oxygen atom. H2O is the chemical formula for the molecule that makes up water. The H stands for hydrogen atoms and the O for oxygen atoms. Each water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. When we think of water, we think about trees. How do you think that trees get their water from the ground? Great! Plants absorb nutrients and water through their roots, but photosynthesis, the process by which plants create their fuel, occurs in the leaves. Therefore, plants need to get fluids and nutrients from the ground up through their stems to the parts that are above ground level. We will discuss the 3 processes that trees and plants use to get their water from the ground. The first thing that we need to know is that water is attracted to water. This is through the process called cohesion. Cohesion is the mutual attraction between like molecules that causes them to stick together. Water is cohesive. Here's an example of water molecules sticking together to create one larger molecule on a leaf. The water is cohesive to each other. Water is attracted to other substances. This is through the process called adhesion. Adhesion is the mutual attraction between unlike molecules that causes them to cling to one another. You can also think of adhesion as taking tape, putting it on a picture, and sticking that picture to a wall. Going back to the same image, we see that the water molecules are stuck on the leaf through the process of adhesion. Through the adhesion of H2O inside the stem of a plant and the cohesion of H2O to each other, plants can easily transport the water from the ground up. This is through the process called capillary action, which is the movement of water along the surface caused by cohesion and adhesion. Here are definitions of the processes we just discussed. Take some time to write down the definitions with a paper and pencil. Here's a moving graphic of the interaction of water molecules in the xylem cell wall. You can see that all 3 processes are occurring here. We have adhesion between the water molecules and the xylem cell wall, cohesion between both water molecules indicated by this dotted line, and capillary action, which is the process of cohesion and adhesion, the movement of water molecules. We will be doing 2 activities now that will show other processes and instances of water. Hi everyone, my name is Kate, and we're going to start with our first H2O activity. The things that you will need for this activity is construction paper, a black marker, and your half-filled water cup. The first thing we're going to do is sketch out 2 arrows, one that points to the left and the other that points to the right on top of each other. I'm going to give you some time for you to make these sketches. Now that you've finished your arrows, we're gonna do something cool with the water. So, what you're gonna wanna do is hold your water up to both arrows. You can start actually with the first one on top. So do you see the arrow? Maybe if I wiggle a little bit, move to the left, push the water out. Look, it looks like it's pointing in, to me it looks like it's pointing in another direction than how I drew it. Oh, yep. Whoa, look how cool that is. Let's try it with the one at the bottom. Okay, it's pointing in that direction. However, when I pull out my paper, it's the complete opposite direction. I wonder why that is. Well, anytime that light passes from one material into another, it bends, or what we call refracts. In the experiment I just did, light traveled from the air, through the cup, through the water, to the back of the cup, and then back through the air before hitting the arrows, which is why the arrows look like they were pointing in the other opposite directions when they were supposed to be pointing in these directions. Refraction, like cohesion, adhesion, and capillary action, is a property of water. Our final experiment of the day will test how trees get their water with adhesion and cohesion by doing an experiment called chromatography. For this experiment, we're going to first need our half cup of water, coffee filter, and colored markers of your choice. The first thing you want to do in this experiment is draw a circle that outlines the bottom circle of your coffee filter, like I did with the orange. When you're done creating your circle, you're going to want to fold the coffee filter in a triangle, like what I'm doing here. Just fold it a few times until it looks like this. Afterwards, unwrap your coffee filter. And then you're going to want to take it, push it down into your water so that the coffee filter bottom is in the water. And you're going to want to try to avoid putting the color in the water. You only want the part that's the coffee filter to touch the water. And then you're going to leave it and see what happens. After a few minutes, the color of your marker should have spread up the coffee filter like this. So, why did this happen? Coffee filters are thin paper that contains cellulose, the same compound that trees and plants are made of. Cellulose pulls water up by capillary action, a cool phenomenon that we discussed before. Marker inks are made up of many different colored dyes. Each dye is made up of different chemicals, some heavier and some lighter, that travel at different speeds as the water moves them up the paper. Thanks for watching!